All right, this is Mr. Gibbs, also known as Captain Awesome on YouTube. So here's my first inventor tutorial, and this is for my third year engineering course, CIM. We are going to be milling some nameplates for some teachers. So I'm going to just walk you through step by step how I would have you do this. You don't have to follow the exact steps in the milling process. You can use whatever milling tool you want to use. I'm just going to use the one the 3/8 inch, or I'm sorry, 1/8 inch end mill for setting up my tool path. And yeah, we'll just get started. So use these exact measurements for your stock that you'll be using, and we're going to be using 2x4s for the teacher nameplates. So after you pick your teacher nameplate, you're going to open up a new part, and you're going to start a new sketch. And it's like, I know people get really finicky about which plane you start on. I don't, because you're creating it in 3D space, and you could always reset your origin if you did it wrong and you need to have it in a different place. Okay, a lot of people say start at the middle of the origin. I don't, because having those lines connect to each other can get confusing. So I actually say don't attach it to anything. Don't try to line it up with anything. You don't have to worry about other constraints interfering. And now you have a rectangle. You started a rectangle in your sketch, and this rectangle is eventually going to be a 2x4, and it's going to be a 2x4 that is 11 inches long. Okay, so you'll cut a 2x4, your stock material, to be 11 inches long. All right, and then we'll have it be, oops, sorry, here we go. And then we're going to make that 2x4 3.5 inches tall. So a 2x4 is not actually 2 inches by 4 inches. That's the rough cut on it. And so when you go buy a 2x4 from the store, it's usually right around 3.5 inches. It's not exact. They don't mill it to precision, so it can vary quite a bit. But we'll use 3.5 for our measurement here. Okay, and then we're going to finish that sketch. And we're going to extrude it, and that's going to be not 2 inches, sorry, it should be 1.5 inches. So the 2x4 is actually not 2 inches by 4 inches, it's 3.5 by 1.5, so they take a half inch. Okay, so there's the beginning of our nameplate. So that's really the biggest part that you'll need. The milling machine, when you actually put in your letters here, the milling machine that we're using is limited to about on the X and Y axis, a 10 inch by 6 inch square. So we're just going to actually match it up with a 10 inch by 6 inch rectangle. We're going to match it up here and constrain it to that line. Okay, and you see how I left some space at the edges? Well, that's because the milling area, or the working area that in our milling machine, is only about 10 inches. So we're going to go 10 inches, and there should be some space on the side. You notice that it's not even. Well, that's because we need to dimension the whole thing. So a lot of times people say, well, you know the measurements, you know it's 11. Well, yeah, you do know it's 11, but what happens if you change that 11? And what happens if the piece that you cut, you want a cut that's 12 inches long? And then you'd have to go back and change a second set of dimensions. So what I do is I actually take the constraint-driven dimension up here, and I use that in an equation. And I'll click on the edges here. And then I can actually write an equation here, and we'll do our overall block of wood, which can change. If, let's say, we made it a longer extrusion for our original block of wood, our stock, we're going to subtract out what our box is here. And the milling area is just like, I think it's 10.6 inches, but we'll just use 10 inches. And as long as we stay within 10 inches, you're going to be good. So we're going to write this equation, right? And we'll put some order of operations around there, so some parentheses, so that we know that subtraction is happening first. And that's actually going to come out to be 1, right? but we want it to be 0.5 so that it has an even space on both sides. So we're actually going to divide that by 2. All right, so now we have that centered in there. All right, and then let's dimension it to the top of our line here. There's other constraints that you can use, but we're used to using the dimensioning tool, so we can actually just make that dimension between those two lines 0. All right. So there we go. So now I have a box, and really this box is a guide for your for what you need to have your text inside of. So as long as your text stays inside of this, you're good. So you're going to use text, start a new text box here, and something on this guy will pop up. And my name is Mr. Gibbs, so I'm going to make mine real quick. I'm going to say Mr. Gibbs. All right. So it is best to stick with the text that is really clean lines, because if you try to extrude something that it like a really fancy font, it won't extrude it, and you'll have to do some funky things. And we still might have to do some stuff to this one, even using the embossing tool. So some people use the embossing tool. Sometimes that's a little finicky. You can also use the extrusion tool. So I know that's not the by the book procedure on how to do it, but it gets the job done, and sometimes getting the job done is pretty important. Okay, so we have 0.12 inches tall here. Well, that's not going to be tall enough for us. You see how small it is compared to the rest of the sign. It's not really what we're looking for here. So we're going to double click on our words. My computer's trying to catch up here. Come on. And then we can highlight that. And we know that the block of wood is 3.5 inches tall. So to give it some space on the top and bottom, that gives us a little margin for error. Let's say we'll call it 2 inches, and we'll make it 2 inches tall. Let's see what that does. Okay, so we can see that my name actually popped down. So I am going to delete that. Oh, I need to make my text box bigger. Okay, so you notice how my name does not fit inside those two blue lines. So we're going to have to change that. So we're going to have to make it a little bit smaller. So maybe we can try 1.75. And there, my name fits inside the blue box. Yep. All right, so we're in there now. Okay, so I'm going to finish sketch. I've got my text in there, and you can either extrude or emboss the text. If you do run into an issue with this, so we're embossing it and we actually want to do a cut on it. And so name cut in there. All right, so now we have something that we can actually mill. So next up is going to be setting up our cam. So we have our cam, we need to do a setup on it. Okay, so this is not the only way to do this as far as your setup of your cam, but you do need to pick the lower left-hand corner for your milling operation. And so this one worked out nicely. I used the right plane, so my X and Y and Z all line up perfectly. But let's say it didn't. Let's say I changed it. Let's flip my Z axis. Okay, so let's say my Y axis and Z axis weren't going off in the right direction, right? We want them pointing the X axis down my name, the Y axis up going to the side of my name, and the Z axis pointing up. Well, you can always select like Z axis, okay, and it's already selected, so it's kind of obvious, but you select a line going up and down for Z, and then if it's pointing the wrong way, you can say flip the Z axis, okay. You can always select any X or Y or Z and change what axis that belongs to. And are you gonna listen? change there. It didn't like me that day. Well, you can always change it. So we selected Z. I think that's why it's not letting me change axes. But you can always change that. You can, well, almost always for some reason. I said always, but this one's not working for me. But you definitely want to select the lower left-hand point and play around with your settings in here to get the correct Z axis. So again, you want the lower left-hand of the name, whether it's a Mr., Miss, whether you call your teacher a nickname or whatever it is, that's going to be their name tag right here. All right, so set up your stock. We're going to keep this really simple. You're not going to have any stock offset. Okay, so we're going to change both the top and the side to 0, and we'll hit OK. All right, so now you're actually ready to start setting up your milling paths. All right, so you're going to set up the one I like to use for this project, and it does leave stuff in the middle of it, which is fine by me if that's how you want to do it. If you don't want stuff left in the middle, that's what we call a pocket. I'm going to use a 2D contour, and a contour just follows a line. So I'm going to hit 2D contour, and I'm going to set up my milling path right there. So I click on that edge, and that blue line is the path that this is actually, the bit is going to follow. Okay, and so we're going to change our tool. I'm going to select our tool here, and you go down to PLTW libraries, and we're going to do an engraving tool. I'm going to choose an engraving tool. So actually, no, I told you guys I was going to select a 3/8 inch end mill. So let's do that. Sorry. Okay, so end mill means that it's flat, so or 1/8 inch end mill. So there it is, right there. Okay, you could choose the engraver, completely okay with me. And then you want to check your feed rates here. So cutting feed rate is 18. That's all fine. That'll work for our tool. And then last but not least, stock contours. I'm not worried about that. The big one that I want you to worry about is our step over and our step down. So you're going to come over to multiple depths. And instead of a maximum roughing step down of 0.4, we're going to change that to half the width of the bit. So we have a 1/8 end mill. So you grab your calculator if you didn't know what half of 1/8 is. And you're going to do 1 divided by 8. And that's going to give you 0.125. And then you're going to divide that by 2. And you should get 0.0625. Okay, 0.0625. And that's a really conservative number. You're not going to break the bit on wood with this one. And it'll be a little bit faster than what they had set it at originally. Okay, so stock to leave, you're going to select. You want no stock to leave. You're going to set it at 0, and you'll hit OK. So my letter M is done. So what I can do is go back and click on my setup and hit simulate, and we should see my letter M get milled. You can see how it's going around the outside. And there we go. It's going to take a couple passes there. Okay, so you can see in here it actually left 2 little spots right there. If you didn't want those spots, you can use the pocket tool. So let's say we wanted to delete that. Okay, and we're going to use a 2D pocket. Okay, so we're going to click on, oh, wait for it. Okay, so we're going to click on our 2D pocket right there. And then we're going to make sure we have the right tool selected. The 1/8 end mill is probably a good one for that. Yep, keep that selected. And then this one, once you select the tool, it'll pop in the settings for you automatically. And again, I'm worried about the step over and the step down. So we're going to change the radial stock to leave as 0. And then let's see, multiple depths. We're going to you were still using the 1/8 inch end mill, so we're going to stick with 0.0625. 0.0625. for. And then it should have a maximum step over. No. Finishing patterns. Allow to, okay, so looks like it's pre-selecting that one. Okay. Oh, maximum step over right there. Okay, so that's actually a pretty big maximum step over. That's almost 100% of the bit. So we didn't want to change that to half the width of the bit again. That way we're not getting any. We're not going to break any of our bits. So we're going to say 0.0625. And we'll see if it'll let us do that. Okay, so you can see it drilling down in there, and we have our tool path, and then we'll hit simulate. Okay, and if you don't like the speed of your simulation, you can always speed it up. Using that little dot. And watch it go on through. I know, this is riveting. This is maximum Hollywood entertainment right here. Okay, fantastic. Okay, so my M is milled, and then you would follow that for all the other letters that you're going to do on here. Okay, so once you have that, once you have all those letters milled out, you would hit post process, and then you would change it to IntelliTech. Okay, so come on down here, change it to IntelliTech. There it is right there, and you would hit post, and then you'd have your, I'm going to call it Mr. Gibbs name tag. Awesome. Okay, so we've got it saved. There's all my code for just that letter. Of course, you're going to do it for all of the letters, and then you can test that out in your in the CNC motion. Okay, so let's go back to this real quick because you do have another step. You are going to do some laser cutting on the back side of this guy. So here's your final step, and this does should be the same. 99% of it should be the same for everybody, except for your name on the back. So you're going to do your name on the back. Okay, and you're going to do another text. And this one can be smaller. It doesn't have to be as big, but things that you're going to write in there, you're going to write your name. And please don't write your name, write your actual name. If your name is John Smith, you need to write John Smith. Okay, so don't write the words your name, write your actual name there. The tools that you will use to make this are tools used. You are going to list them. Tool number 1 is Autodesk Inventor. Tool number 2 is HSM Ultimate. All right, I'm going to hope that I don't spell any of these things wrong. You guys all know how good of a speller I am. All right, so HSM Ultimate. Then you are going to use CNC Motion with the Benchmill 6000. That is the milling machine we're going to use. And then you are also going to use the Boss Laser 2436. And that is the laser engraver that you're going to use. And you're actually going to laser engrave the back side of this so that when you hand this to your teacher, they will know that you know what tools you actually used to create this. So it looks like my text is a little bit off. I can just drag it on here. It doesn't really matter exactly where you drag it. You notice how it's upside down. It's not a huge deal. You can always rotate your block around to be the right side. And we are going to extrude this, and then we're going to export the face. Okay, so let's extrude that. Okay. And we're going to extrude it in, and we're actually going to change it to 0.05. So 5/100ths of an inch. Is it going to do it? Is it going to give me an error? Okay, so sometimes when you try extruding stuff, it doesn't like extruding in. So I've found you can also, if you can't extrude it in, you can extrude it out. Let's see if it'll do it there. And it did it. Okay, fantastic. Awesome. So there's all my extrusions coming out. And because we're just laser cutting that in there, we're going to actually right click on that face, and there should be a way to export face, and you want it to be a DXF file. So we're going to save that in our nameplate. You can make a folder for nameplate. I'm going to go boom. And we're going to export that as a DXF file. So back side, Mr. Gibbs. Awesome. Okay, so once you have that exported, it's pretty easy to import that into our laser cutting software, which I'm going to come back and show you how to do a little bit later on. But you do need to export that DXF file for the laser cutter, and that's really easy to set up in the laser cutting software once we have that. So remember, both sides, you're going to pick a teacher name. I'm going to have you do that in Google Classroom. You'll put it in the comments, and I'll show you how to do that I'll show you how to do that in class once you have turned in your CNC or your HSM Ultimate assignments. So best of luck. Hopefully you guys can follow that. I know it was a really long tutorial. I'll do my best to kind of edit some of the wait times out to shorten it up a bit. If I can't, there's always the speed it up button, and you can always use that to speed up your process. So good luck.